Alright guys, today we have permutations and combinations. So we're going to learn two new buttons in the calculator, and just as an FYI, if you want to have your calculator out so that you can practice starting to type these, you're going to be under the math option. Math is a specific button on your calculator, and if you arrow all the way over to probability menu under the math key, then you have these things that I'm going to be talking about. So just get your calculator out, find the math button, and then arrow over to probability just to get ready. But the two topics for today are permutation and combination. Big, huge, important difference about the two is that a permutation has a specific order, so it represents the number of ways to arrange things in a specific order. A combination, on the other hand, is where order doesn't matter. You're just simply putting people into groups. It doesn't matter whose name I call first because you're all going to be in the same group. So I also have some keywords and some formulas for you just to get copied down here. Keywords for permutation when order matters is arrange, order, position, schedule, because you're thinking like first, second, third is important. If you're doing a combination, then your keywords there are choosing, grouping, forming a committee of some sort, taking a sample, or selecting, or most deck of cards problems have to do with combinations. So these two formulas have to do with factorial. Notice that the big difference here is this one does not have an r factorial in the denominator, but this one does. So just keep those in mind, but NPR and NCR are the two buttons in the calculator we're going to be using. Again, go to Math, arrow over to Probability, and then you will find NPR and NCR, and also your factorial button is all in that menu. But just to kind of introduce the difference between permutation and combination, I've got to give a shout out here. I've got two students. Pretend they're Crystal and Liz. What's the difference between a combination and a permutation? So big major difference. Let's say that I am pairing students up. Then it doesn't matter whose name I say first. If I call Crystal first or if I call Liz first, regardless, there's only one way to put them in a group. It's by calling both of their names, and the order doesn't matter. There's only one way to put them together. This is called a combination. However, if I'm pairing students up but I give them jobs, let's say I make one of them like the writer, they have to go to the board and write something down, and the other person is allowed to use the calculator, then there's actually two ways that I could pair them up. So Crystal being the writer and Liz being the calculator, or what if I called Liz's name first? Liz would be the writer and Crystal would be the calculator. That represents two different ways. That is a permutation because the order in which I say the names matters. It designates them a specific position. Okay, so that's the big difference between combination and permutation. So start kind of thinking about that. But let's look at a couple different practice problems here. So if I have 10 competitors in a dance-off, how many ways could I award first, second, and third place? So here is something very important. This tells me that order matters. And so important thing here is that we are going to use a permutation, and I can also use the slot method. So I'm going to write down permutation. And the symbols for that, which you wrote up there by the formula, is out of 10 competitors, permutation of 3. And so that's what you're going to use in the calculator, or you could use that formula at the bottom or at the top that you wrote. It's also written as permutation 10, 3. Some calculators have you type it like that. So two different symbolic notations here. Again, it's a permutation because I'm awarding first place, second place, and third place. The order matters. The formula for that is 10 factorial over 10 minus 3 factorial. Okay, so 10 factorial over 7 factorial. You can do that. You know how to simplify that. We went over that yesterday. But also remember that the slot method works here too. How many options are there for first place? There's 10 teams. But then after that first team has been awarded their first place, there are 9 teams left that are competing for second place. And then third place, there are 8 teams left. So it's the exact same thing as this, because remember that the 7 factorial is going to cancel, so you're just going to have 10 times 9 times 8 on the top, and that gives you 720 ways. I challenge you to try typing this in your calculator. You're going to have to hit 10, because that's the first number here, and then go to Math, over to Probability, NPR, and then 3. So in the calculator, what that's going to look like is 10 NPR 3 in the calculator. Find that math button and then arrow over to probability. You could also Google how do you do permutation or combination in the calculator. I'll go over it in class again tomorrow. But let's look at number 2. There's 10 people trying out for a dancing role in a music video. 3 people are going to be chosen. How many different groups of 3 could be chosen? So keyword there is choose. This is a combination because we're only choosing 3 people. It's not first place, second place, third place. It's just groups of 3. Strictly, it doesn't matter which order you call the people in because you're just placing them in a combination. So out of 10 people, choose 3. Same symbolic notation as writing combination 10, 3. The formula for that is 10 factorial over 3 factorial 10 minus 3 factorial. You know how to simplify that. We've practiced that. I challenge you to try and type this in the calculator. And so when you type that in the calculator, you get 120 ways. Okay, so big difference between choosing out of 10 3 people and putting them in place. There's a bunch of different ways to do that versus out of 10 people strictly putting them into groups of 3. That's only 120 ways. How many ways are there to line up 8 students? So putting them in order, meaning first, second, third, that's a permutation. And so again, all we're doing is out of 8, permutate 8 people. It's the same thing as 8 times 7 times 6, blah, 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 blah. 8 factorial. It's all the same thing, and so that is kind of what we've been discussing over the last day or so. That gives us, if you could check this in your calculator, 320 ways to line up 8 students. All right, 12 people in a ghost hunting club. I need to select a 4-person exploratory committee. That is a combination because I'm not putting them in specific jobs, just putting them in groups of 4, basically. So again, out of 12 people, choose 4. Go ahead and type that into the calculator, or you could try using the formula that's written up above, 495 ways. Okay, we've got 22 players trying out for the baseball team, and we're only selecting 15. How many different ways are there to pick the team? So you're not selecting like first place, second place, third place. Again, you're only choosing 15 players. So out of 22 players, choose 15 of them. It doesn't matter what order the coach calls their names because all 15 of those people are on the team. There's a bunch of different ways to select that. Verify this in your calculator. If you're having calculator issues, of course, what I can do is help you in class tomorrow. But if we are selecting, that is a combination. So big point for today for the notes, you guys, is to make sure you understand the difference between permutation and combination, okay? Once 15 players are selected, how many ways are there to make a batting order? Okay, so order means permutation because you are selecting like who's going first, who's going second, who's going third, whatever. In this case, full disclosure, I had to look up how many batters there are for baseball. Okay, I'm really, really sorry, Tyler, and anybody else who plays baseball. I did not know that you choose 9 people to go up to bat. Okay, I had to look it up. Big deal. All right, so out of 15, permutation of 9. So we have 15 players on the team, and I'm selecting 9 of them to go for a batting order, where the order matters. That is a permutation. That gives you a ginormous number. Verify this in the calculator. 1,816,214,400 different ways to line up 15 people, to line up 9 of them out of 15 people total. Okay, you guys, now we've got a little bit of deck of cards situation. So if you're not familiar with what the cards look like, there are 4 suits. These are called spades. The next one, the clovers, are called clubs. Then we have diamonds and hearts. And there are ace, 2 through 10, and then jack, queen, king. And ace does not have a face on it, so those are not face cards. The face cards are these, jacks, queens, and kings. But here's your deck of cards in case you're not familiar with cards. And then I have a couple key things for you to note. When events occur simultaneously, that means and, you multiply. However, if the question is an or, you add. So those are a couple formulas that hopefully you remember from regular geometry class. You briefly touched on this, I believe, a couple years ago. But if we were going to do how many different 5 hard hands are possible in poker, order doesn't matter. You're just grabbing 5 cards and putting them in your hand. So this is a combination. And again, I wrote most card problems are always card problems or combinations. We wrote that up at the top. Did you know there are 52 cards in a deck? And choose 5 of them. How many different 5 card hands are there? 2,598,960 different hands, meaning combinations of 5 cards. How many 5 card hands are possible that have 2 hearts and 3 clubs? Okay, so this is going to get a little bit more tricky, but we have to have 2 hearts, and so there are 13 hearts total. I want to choose 2 of them. It doesn't matter which 2 or which order I pick, but there are 13 hearts up in that picture up at the top. I want to choose 2 of those, and means multiply. And then for 3 clubs, there are 13 clubs also, and I want to choose 3 of them. So here we are doing 2 different kind of mathematical operations. So in the calculator, 13 choose 2 is 78 times, in the calculator, 13 choose 3 is 286. When you multiply those together, you get a pretty large number, 22,308. Okay, 2 questions left. Let's see, how many 5 card hands are possible that have 2 jacks and 2 kings? So again, and means multiply. And so how many jacks are up there in the deck? There are 4 jacks, and I want to choose 2 of them. And for 2 kings, there's also 4 kings up there. I want to choose 2 of those. Again, it doesn't matter the order, because if I pick the diamond first or the heart first, it doesn't matter because it's still the same hand. And then that only makes 4 cards, you guys. So I'm choosing 2 jacks and 2 kings. So out of all the other cards, I need to have 1 other one. So this one's a little bit weird. And something else for the 5th card. So I'm going to multiply again. And how many cards are left that I haven't looked at yet? So I've looked at all the jacks, so throw those out. I've also looked at all the kings, so throw those out. So 52 minus the 4 jacks minus the 4 kings leaves me with 44 cards left. I need to choose 1 of them because I'm supposed to have a hand of 5. So I have 2 jacks, I have 2 kings, and I have to have 1 of something else. I'm not exactly sure what it is, but it has to be a different card. So out of 4, choose 2 in the calculator. This is 6. 4, choose 2 again in the calculator is 6. 44, choose 1 is 44. And when I multiply all 3 of those numbers together, I get 1,584. Okay, you guys, so what I'm going to do is save this very last question to do tomorrow because it's kind of a challenging one. That concludes the video. I know I went kind of fast through those, especially the card questions, but we'll have time to practice in class tomorrow, ask questions, do a couple problems together, and then get working on the worksheet, okay? So thanks for watching. Have a great night. I will see you tomorrow.